At first glance, geography and climate seem like things that should be completely separate. After all, what do physical landforms have to do with temperature and the movement of water through Earth's atmosphere and oceans? As it turns out, quite a lot. Geography and climate are intertwined in numerous different ways, and some of them might be pretty unexpected to an outside observer. So, how does physical geography affect weather and climate? Now, before I get into that, I'd appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so let's start out with something pretty simple. As your elevation increases, the overall temperature usually decreases. This seems a little bit counterintuitive at first. Since hot air rises and cool air sinks, wouldn't you expect higher altitudes to be hotter? Well, there's one quirk that upends this assumption. As the warm air rises, it moves into regions of the atmosphere that have a lower pressure, or in other words, it's thinner. As a result, this warm air expands because it can, and as it expands, it cools since the air molecules themselves are releasing energy. So, to put it bluntly, the air is cooler as you go higher because the atmosphere itself is less dense. However, there are some crucial exceptions to this rule, and this is where geography comes into play. Say you have a really clear night in a mountain valley during the dead of winter. What will happen is that the air near the ground will cool down faster than the air above it. And since cold air is denser than warm air, it will sink down and become trapped in the valley. This process repeats until you have a shallow layer of very cold air on the valley floor that is trapped by the slightly warmer air above it, which in the right situations can lead to some extremely cold temperatures. These inversions are the reason why the coldest temperatures in mountain regions during cold waves are in high alpine valleys as opposed to the tops of the highest mountains. Inversions can actually be extremely problematic in some cases, since the cap of warm air traps just about everything from rising, which includes smoke and pollution. This can cause air quality to take a significant hit, which can cause real damage to personal health and hygiene. Okay, so apart from causing valleys to get way colder and dirtier than they need to, how else does geography influence climate? Well, it turns out that a mountain range can have a rainforest on one side and a desert on the other. How is that possible? It all has to do with something called the rain shadow effect. Let's say you have a warm, moist ocean to the west of a mountain range. What will end up happening is that moisture will roll off the ocean and onto the mountains. As these clouds are being forced up the side of the mountains, something very interesting happens. Moisture is actually being squeezed out of them and to form precipitation in a phenomenon known as orographic lift. This can cause some pretty incredible amounts of precipitation to fall on the slopes of these mountains, in some cases enough to make them a full-fledged rainforest. Once the wind reaches the crest of the mountain range, it has been sucked almost completely dry of moisture, so it races down the other side as a much drier and hotter system, which in turn makes the other side of the mountain very often a bone-dry desert. One notable example of this actually happening is the Hawaiian Islands. To the east and northeast of the islands blow moist trade winds that crash up against the archipelago's numerous volcanoes, which causes some of these slopes to be among the rainiest places on Earth. However, the southern and western slopes of these islands are much warmer and drier, since the trade winds have no more moisture left to give. There are obviously many exceptions to this rule, such as when a hurricane or some other storm not associated with the trade winds hits Hawaii. But the interactions between these winds and the numerous mountains Hawaii possesses form the basis for the archipelago's overall climate. To round off the video, let's move away from mountains and move towards something else that can drastically shape a region's climate: lakes. Right off the bat, these lakes already make an impact since being near a large body of water in general tends to moderate the extremes of summer and winter temperatures, thanks to water releasing heat significantly more slowly than land does. However, while this goes for any sized body of water, from rivers all the way to oceans, there's one thing that makes big lakes in particular stand out: lake effect snow. This phenomenon happens during the late fall and early winter when a mass of colder air moves across warm, unfrozen lake water for a prolonged period of time. Because the lake water is still liquid at the surface, water vapor rises into the cold air above and freezes in very significant quantities. Then, these clouds move off onto the southern and eastern coasts of the lake, where all of this accumulated moisture falls as snow. This phenomenon is most infamous in the Great Lakes region of the United States and Canada, where the significant size of the lakes, the cold winters that the area sees, and the fact that the lakes usually don't freeze until very late in the winter produce the perfect conditions for some serious lake effect snowstorms. These storms are notorious for producing copious snow totals, in some cases on the order of feet/meters in some regions, while other regions just a short distance away hardly get anything. It all has to do with the exact wind direction during the storm and the specific geography of the areas being impacted. However, this phenomenon isn't limited to just the Great Lakes. Another notable instance of lake effect snowfall comes from the Great Salt Lake in Utah. The fact that the Great Salt Lake is, well, saltwater doesn't affect anything since saltwater still provides moisture to the air just the same. However, something that saltwater does do is that it can make the same amount of snow from less moisture due to some inherent properties of saltwater itself that I can't really explain here. This can combine with the ability of the nearby Wasatch Mountains to squeeze moisture out in a similar fashion to what I described earlier. And the result is that many snowstorms dump many feet/meters of light, dry powder, which, if you know anything about skiing, is just about perfect for having a blast. The sheer quantity of this perfect snow, combined with the nearby presence of Salt Lake City, have helped to make northern Utah one of the leading destinations in the world for top tier skiing and snowboarding, with numerous ski resorts and towns in the region seeing millions of visitors each year. So, the moral of the story is, if you ever find yourself skiing in Utah and enjoying it, you have geography to thank. And that's all I have to say about geography and how it influences weather and climate. For now, there are many other ways that the two come together and interact, and I can honestly make several videos detailing why. If you want to see more, let me know down in the comments. And as always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.